Number two, you've got manufactured housing, which a great number of people live in. So the houses are not as well built. They don't have the structure. They don't have the basements. And a house without a basement is a very dangerous place to be. Also, the storms that affect them usually are in the February, March, April timeframe. And it's not the typical tornado season that some people say with spring or summer. Also, they tend to hit at night when most people are supposedly safe in their beds. So the threat is very significant, and it's growing down there, and we're trying to get people aware that you need to be aware of thunderstorms in your area in this time of the year, especially at night. They can pose a very, very significant risk. Next. So here's the EF0, EF1. About 70% of all tornadoes are in this weak category. And there are over 1,000 tornadoes annually in the United States. Most of them are weak. A well-built house is going to offer adequate protection. A car, a mobile home will not be adequate. So if you know anybody who's in those type of houses, when there's a threat for severe weather, they need to be thinking about where they're going to go for shelter. Next. Strong tornadoes make up about 28%, or about 280 tornadoes a year. And even a well-built house is going to lose most of its walls. I'm going to show you a video of a town in Arkansas called Earl that was hit by an F3 tornado, and a lot of buildings completely except for an interior room. Next, please. And then the violent tornadoes, only about 2%, but these things are going to completely level a well-built home, even if it's made out of brick. So the only safe place in there would be in a basement. If you're not with a good basement, you need to seek shelter elsewhere. Next, please. We also have non-supercell tornadoes. Tornadoes are a little bit weaker. They're called spouts. I'm just going to go through this really quickly. These are a couple of land spouts, common out in Colorado. We'll get them around here, or maybe along the Gulf Coast. Next, please. We also have a lot of vortices, or a spinning column of air that looks like a tornado, but they don't offer too much threat, like a dust devil, or maybe something along winds out in the field just blowing across, kicking up some dust that swirls in a vortex. Next. There are products that are going to be given to you via your local media outlet, National Oceanic and Atmospheric Administration, NOAA Weather Radio. And the one that you need to know about, or the two, is one of them is the Weather Watch, a severe thunderstorm watch or tornado watch. And that means conditions are favorable for the development of severe thunderstorms that may produce tornadoes. The next one, and that's usually like for 6 hours over large stretches of a state, for instance. The next slide is a weather warning, and that's issued usually at about the county level. And there can be a severe thunderstorm warning or a tornado warning is issued when it's detected on radar or a spotter has reported this to their emergency management or the weather service. Most important thing here is when you hear a warning, you need to seek shelter immediately if you are affected by that warning, because that's imminent danger. I mean, it's going to happen right away. So if you are under a severe thunderstorm or tornado warning, take shelter immediately. Stay away from windows. A long time ago, we used to say, open the windows. You don't want to go anywhere near a window. You know why? A tornado can open the window for you. So stay away from that flying glass. Get to shelter immediately. Next, please. Here in Chicago, in Northeast Illinois, we are part of a network called Multi-County Skywarn, where we have 15 counties working together to try to help each other provide warning time, lead time for the warnings for all the people in Northeast Illinois. And that encompasses around 7 million people. Next. Nationally, there's a program called Skywarn. And we try to get everybody very aware of Skywarn. I'm sure some of our panelists who are involved with FEMA know this. It's a way to get people trained to understand what to do in case of severe weather, how to spot for it. And I would really recommend, as many people who are interested in this, contact your local National Weather Service office and have them come out to your community, to your mosque, wherever, to a community location to give some spotter training. And they'll train you on how to detect these things ahead of time. So just contact them and they'll be more than happy to come out and help you out. Next. Here's just a couple of pictures we'll go through quickly. A large tree that's uprooted. A tree that's uprooted is pretty dangerous. A tree that's snapped in half, the winds are probably twice as fast. Next, please. Here's some high-tension power lines coming down. Those are big things to be blown down by the wind. Next. Here's some damage that happened out in Illinois last year. Next. That's a piece of aluminum siding that split into a telephone pole. Okay, that would hurt if you were that telephone pole. Well, maybe it wouldn't hurt. It could be over really quickly. So, next, please. Here's some video. A tornado that was out in southeast Colorado that one of my students who's here today with me took this picture. Next. Here's a big cell. This was in western Illinois. Next. A fantastic structure of the whole supercell thunderstorm. And I think the next one is video. Oh, is the video on the next one here? Or did I put it in the wrong place? We'll go with this. This was a tornado that we were chasing in Earl, Arkansas. We were chasing it. It was moving at about 40 miles an hour, which is extremely fast. And I wanted to show you a little bit of what it's like to actually be on a storm chase. As it turned out, Earl, Arkansas is a very poor town. And it went right through the heart of town. Fortunately, nobody was too seriously injured. Nobody died. I think there was one person caught in his pickup truck that broke his back. But fortunately, there was no deaths. However, it's a very poor town. They didn't have adequate warnings. The sirens weren't all working very well. Something that we need to push our communities, try to make sure we have adequate warnings. So, any luck with that video? Okay. Here we go.
That's violent.
That's a violent tornado, guys.
A lot of speed in that one. That is large and violent.
This is a mess. Okay, slow down. Holy shit. Keep going. Oh, find a place to pull over.
Well, we haven't got a lot of shoulder here. I don't think
Just go up a little bit. No, just go up a little bit more. Keep the film going.
We're not going to have a lot of trouble with traffic, I don't think.
Oh my God.
We need to get some good video of this one.
I want to go by that town.
So, big, giant tornado. And for us, we're seeing it as it's moving into a town of several thousand people. So our job as a storm chaser was to call 911 and say, there's a tornado, get the siren sounding. Fortunately, that event ended fairly happily, except for the amount of damage. And the tornado was on the ground for 40-some minutes. And it's a big tornado. One of the scary things, and I just want to end my talk with this notion, as we're driving further to the north and we're chasing right behind this tornado, and we've got the video out the front window, a school bus is driving right next to us, totally oblivious of this threat half a mile away. So people, I urge you, make sure that the kids' schools in your neighborhoods know about severe weather, and make sure that you ask the administration there if they've prepared for severe weather. What are their plans? Last year or 2 years ago in Glen Ellen, St. Charles, there was a big windstorm, and they sent the kids home in it. And people are driving along the road, picking up kids as this 80, 90 mile per hour wind is knocking down trees all around them. And the school district did not do a good job. They were not prepared for this. So urge them to get involved with their communities, talk to people from FEMA, talk to the National Weather Service, but that's how you protect yourself. These things are going to happen, and it's really good to be prepared. So with that, I'll end my talk. Thank you very much.
Can we give Dr. Paul another round of applause, please? As we watched and listened, you could hear keywords: rain, hail, earthquakes, strong wind. Oh, y'all don't hear me. Bringing up our next presenter, please give a big warm round of applause from Purdue University, Dr. Michael Baldwin.
Thank you all. I just want to start out echoing what Paul said, and I appreciate the invitation to come and talk to you today. I'm interested in both presenting some of the extreme weather events that have happened recently, but also here to listen. And one of the important parts of being prepared for disasters is communication, and it has to be a two-way street. And I'm very interested, as all of us are, in trying to improve disaster preparedness, particularly involving severe and hazardous weather. So we'll start off the first slide I have. That's a picture that my son took, and I really love that picture. The next picture I actually took this morning. We had a little bit of snow down in Indiana last night, and it looks like you didn't get any up this way, but it sounded like the forecast is for another inch or two of snow this weekend, and that will set the record for Chicago for February snow, mainly due to the one big storm that was in the beginning of the month. So we'll go to the next slide. I just kind of wanted to start and connect the talk that I have to a bit of my history, sort of introduction, and also to let you know that the definition of extreme weather kind of depends on where you live and what type of weather is normal for that area. And I've been interested in weather since I was a kid. We'll go to the next slide. There was a big tornado outbreak, the biggest one that we're aware of across the South and the Midwest, April 3rd and 4th, 1974. Click the next slide. We should see a map that shows the paths of all the tornadoes. This is Professor Ted Fujita's famous map from the outbreak from those days. And I remember this as a kid. The long track tornado that goes through sort of the northern, towards the northeast part of Indiana. I lived just a little bit south of there. That's a tornado that devastated Monticello, Indiana. And so I have some faint memory of this as a kid, and it definitely inspired me to study these types of phenomena. If you click the next image, I had a student go back and study this case. We have some satellite imagery from that time that was archived, and here we can see the locations of the storms. This is late in the afternoon on the 3rd of April, and there were quite a line of thunderstorms going through the Midwest, and a large bank of clouds back over the northern plains where there was a lot of snow. The next slide actually had my student run a numerical weather prediction model for this event so that we could try to see if the current prediction models could simulate this event. And it turned out to do a pretty good job. And what you see here is a simulation of the radar, which indicates the strength of the precipitation and the winds as well. And the sort of yellow and red colors, which might be hard to see, represent the very strong thunderstorms that are being predicted or simulated by this model. And so the way these models work, we try to combine all the different physical processes that affect the movement of the air, the amount of moisture that's in the air, the temperature of the air, the pressure, and turn those into mathematical equations and get large computers to crunch through those. And we're able to generate now forecasts, simulations that look pretty realistic. And so the group that I work with at Purdue is starting to use this approach to study historical events and try to see if there's been any changes in the characteristics of precipitating weather events in the past 30 years or so, and also to look at the future and to run these models inside of a climate prediction model to try to see if there'll be any changes in the future climate. The next slide is related to this and shows a diagnostic parameter that we use to look for the rotation in the storms. And so the red areas indicate storms that do have rotation, and it would be potential supercells. And so we use this event to sort of calibrate and to demonstrate that we can do this. And we have students at Purdue that are now generating decades worth of data that we're going to analyze. We're still preliminary in this work, again, to try to see how things might be changing or might change with climate change. So the next slide, another event from my past, and this is, there were two blizzards that happened 1977 and 78 on this almost exact same date, January 25th. The next picture actually shows pictures of me, and as a much younger man. The snow that we got in Indiana added up to about 1.5 feet, and this is known as the blizzard of 1978. There's actually a couple famous blizzards from that year, one for the East Coast and one for the Midwest. And so we do see these extreme weather events happening in the past, in the current, around the world and in the United States. Let's go to the next slide. After Indiana, we moved to Mississippi, where I lived for a year. And the thing I wanted to mention about Mississippi, we lived in the Delta, close to the river. If you click on the next picture, if one flake of snow falls in Mississippi, they close school. So that is extreme weather if you live in Mississippi. And so part of the, again, the definition of extreme, it depends on where you're from. And the next slide, I moved on to Michigan after living in Mississippi. And I remember the drought in 1988, which was very long heat wave in the summer in the Detroit area where I lived, and but had a widespread effect across the Midwestern United States. And drought is, I think, a more subtle extreme weather event. Unlike tornadoes, which will sort of come out of nowhere, surprise you and hit you, a drought takes a long time to develop, but the results are just as devastating. The monetary damage for this 3-year drought in the 1988 dollars is estimated close to $40 billion. And you have to take into account the effect on agriculture, on water supply, on the power generation. All sorts of things are affected by this kind of event, as well as heat-related deaths, which obviously are devastating. So the next slide, I think from Michigan, I went out to Oklahoma, and I would hold Oklahoma up as maybe the extreme weather capital of the United States, but I'm sure we could have a debate about that. Just a recent example, they had, some cities had a 100-degree change in temperature over 6 days. So there was a snowstorm early part of this month. After the snow fell, the temperatures dropped to their all-time record lows. So they set an extreme minimum temperature for the state. The example I give is a little bit warmer, minus 28, and then 6 days later it was 72 degrees. So it doesn't take long in Oklahoma for the weather to change. Also famous for their severe thunderstorms. The next slide, from Oklahoma, I moved out to Washington, D.C. And just again, last year we had back-to-back major snowstorms that affected the mid-Atlantic. We seem to come up with these great nicknames for the storms these days, Snowpocalypse and Snowmageddon. but they were very disruptive events with 30 plus inches of snow across that region that affect millions and millions of people. And anytime we get a big storm in the east, there's going to have a very large impact on the population. And from Washington, it's, I think the next slide sort of goes on to more of the recent extremes and less of my history. So the big event that we had in Chicago earlier this month, where officially 20 inches of snow, I think, was observed at O'Hare. You can see the map here shows the widespread area of very heavy snow. A lot of it came from the lake effect that occurred after the main system moved off, and there was a lot of strong winds with this as well. I probably don't have to tell a lot of you this because you lived through it. But this was a very extreme event, and as I mentioned, will probably help to set the record for February for snow. The next slide. If we look at the pattern that we've had for this past year, we've been in what's called a La Nina pattern. And the La Nina is basically the opposite of El Nino, and these are different patterns of sea surface temperatures over the tropical Pacific. And the colder pattern is called La Nina, where the temperatures are actually colder. And the typical effects on the jet stream and the storm track are shown in this plot, where we see a lot of the flow coming from Alaska, a lot of cold air coming down into the central U.S., but a typical average La Nina is actually relatively warm for the Midwest. So there was a bit more going on this year, and the Arctic oscillation is the next thing, which the next picture will show. The polar region gets very cold in the winter, obviously, and what results is a very strong vortex that has strong winds that wrap around the pole, and typically that will keep a lot of the cold air sort of trapped over the pole. This year, we've had the opposite. We've had relatively warm air over the pole and a weak polar vortex, and that allows a lot of the cold air to kind of break off and move south. And you can kind of see on the right there, the storm track heads more towards the East Coast, towards the Midwest, and we get colder and snowier type of pattern. And so that's what we've seen this year. The next slide shows sort of the average. This is called a negative Arctic oscillation pattern, where, again, the pole, the warm colors there show relatively warm air over that region. So Greenland and the North Pole were relatively warm. And then the blue shows relatively cold, and those solid lines show the basic track of storms that we would have with this sort of pattern. And this is basically what we saw through most of this winter. The next slide shows another sort of picture of this called what we call it a blocking pattern, where the storm track comes out of Alaska and we get this very cold air. And so most of what we saw this winter would be a day or two of snow followed by a day or two of very cold air and a repeat of that over and over again. And I think the next slide, I'll just go ahead and skip this. So we'll go to the next. The one speculated reason for this is the Arctic sea ice. And what we've seen, the polar regions have gotten warmer and warmer and warmer over the years. And more of the sea ice over the North Pole and over the Arctic is melting during the summer and fall. And so we have more open water, and that is warmer, and that tends to warm the region around the North Pole. And that would help to explain why we have this Arctic oscillation pattern that we saw. You can also see the trend over the last several years for the sea ice that we have for this time of year, January, is getting less and less and less as well. The next slide, I believe, shows that at the very peak of the melting of the ice, we actually had the Northwest Passage opened for the first time, and so you could sail a boat across the Arctic Ocean and go from Greenland to Russia the short way, which hasn't happened before.